CBT Nuggets Security Plus Access Controls Part 1. Well, this is going to be the first of two pretty beefy and somewhat lengthy nuggets on access controls. We're going to cover an entire domain of the CompTIA Security Plus exam. Now, before I dive into our first topic, or at least show you what our topics are going to be in this Part 1, let me just define access controls for you. And you know what? It's exactly what it sounds like. It's basically controlling access to resources, physical and logical resources on a computer or an entire system. Now, what we deal with access controls are subjects and objects. Subjects can be users, they can be systems, they can be applications, and subjects access objects. Objects can be data, they can be peripheral devices, they can be files. So we are controlling access of subjects to different objects. Now, without access controls, we would have, anarchy, chaos, a completely unsecure environment. Employees could see the salary and bonus structure of a CEO. People could read each other's email. Personal privacy medical information could be shared easily. Malicious users could discover the formula for Coca-Cola, for example. Intellectual property, strategic plans, all let loose into the ether. Well, obviously, we have to have access controls in place. We have to identify users and systems, authenticate them, authorize them, and account for them to truly have security. And that's what we're going to look at here in these next two nuggets. In Access Controls Part 1, we're going to look at four key areas. First, we're going to look at some best practices that CompTIA wants you to know for access controls. We'll look at four concepts: the least privilege concept, implicit deny concept, the separation of duties concept, and job rotation. Then, we'll look at common access control models. We'll also look at specific things we can do to organize security groups and rights and privileges, and we'll use Windows 2003 Server, a very popular server, as our example. Then we'll compare and look at implementation of logical access controls. These will be things like ACLs, or access control list. Talk about group policies. We'll revisit the concept of password policies, things like that. And then finally, we'll look at various authentication models as we look at one, two, and multi-factor authentication and define what single sign-on is. Sound good? All right, let's get to it. Now, least privilege is one of three main principles of security. It just so happens that this principle relates very closely to access control. Now, the other principles are what we call defense in depth, which we've already discussed in depth, okay? Defense in depth, or a layered approach to security. A second pillar would be what we call attack surface. Attack surface means minimize and understand all of the ingress and egress points at your organization. All the points of entry, physical points of entry, logical points of entry, electronic points of entry, and all the ways to get out. The third is this concept here of least privileges, or least privilege. And what this simply means, if a user only needs read access to a particular file or a document, or maybe something stored, let's say, in web format in Microsoft SharePoint would be a good example, then don't give them read and write access, okay? If they need to be able to list the contents of a folder or a directory, they don't have to be able to necessarily execute programs in that directory. We want to avoid the laziness of giving default permissions or full permissions to individual users on resources. We don't want to just give out administrative access to anybody in the organization. We want to give them just the least amount of privileges, the least amount of permissions and rights to objects in our organizations that they need to do their job. So the way we approach this is we start out tighter, and then as necessary, we can loosen up the reins on an ad hoc or as needed basis, okay? We can dole out privileges as the job description of a user changes or their level or role in our organization changes. But we start out, of course, giving them the least amount of privileges they need to do their job effectively and productively. And then from that point on, we start to add in more liberality. Okay, here's a little bit of a sidebar. What I want to show you, this is a screenshot from a SharePoint site. And SharePoint's a great example of taking this least privilege concept and tying it to what we call security trimming. In a web-based format, I can take this entire least privilege concept to its logical end, in the sense that somebody can come to a site that is delivered to them in XML, for example, and based on their login credentials, I can not only give them least privilege access, I can literally control so that only the things they see they have access to. In other words, based on my credentials as Michael Shannon, there are things here that the administrator of this SharePoint site can see that I cannot see. They can set it up so that based on my login access, I don't see certain web components on this page. I may not have certain things listed on this menu over here on the side. I may not see tabs or other components that I shouldn't be seeing. And if you think about it, this is really taking least privilege to the next step, because before, somebody could go to a certain area and they may be able to see things, but based on their permissions, when they click on them, they may get dialog boxes that say you don't have access to this or access denied, or they see things but they click on them and they're inactive. This is taking, by using XML, this least privilege concept and totally security trimming out something so that I only see the things I can access. I kind of wanted to show you that as a sidebar of how this concept of least privilege is really being used in a web-based format. This next key best practice is implicit deny, and this is pretty much built into most network operating systems and access control mechanisms of network devices. What this means is, unless you explicitly grant access to a user or a group of users or a system, it's implicitly denied that they have access. Let me show you this in a couple different examples here. I'm going to go first of all and just go down here into my Vista machine into a folder called Michael. I'm going to right click on this file folder called Contacts, and I'm going to go and apply some share permissions. And this applies to users that want to access this particular folder over a network. So if you see here, we've explicitly had Michael, who is the owner of this particular folder, as the owner and has full permissions. If I go in here and add, let's say, James, until I added James as a reader, James was implicitly denied access to share this folder. I had to go in and at my discretion, Michael, the owner, I had to grant him permission to access this shared folder over the network. Until I did that, it was implicitly denied to James. Okay, that's one concept. Let's go take a look at a router, and I'll explain a different concept of how implicit deny can be used in a access control environment. Okay, I'm over here on a 3725 Cisco 3725 router, and let's say that this router is between the core of my small to medium sized business and an area where I have a bunch of training that goes on. I've got, let's say, 20 to 25 training computers in there, a departmental server, printer, and all that. And what I want to do is I want to kind of isolate with the access control that particular area from the rest of my company. So I would go create an access list. And in this access list, which I'll number it, I'll call it number 101, I want to permit all IP traffic to this router interface coming inbound, okay, from network 192.168.100.0 with a 255.255.255.0 subnet mask. So basically, it's network 192.168.100, and then I'll have about 254 hosts on this. So from this range of addresses to any address. Okay, hit enter. So this is my access list, number 101. So I'm allowing traffic from this network where my training machines are. I would apply this inbound on my router interface to control access, so that any other device with a different IP address than this, for example some rogue device, can't plug into a switch and get access through this router. Now that's great, but what happens with Cisco access control lists, like all other secure network operating systems, is this. This is the first and only entry in this access list, but there is an implicit deny, which means I'm permitting all IP traffic from this network to any other network, but there's an implicit deny so that everything else is denied. And that starts out with that fundamental truth, okay? You permit what you want to allow, and then everything else is going to be denied. So that's another way we see implicit deny used in access control lists in a networking environment. The next best practice is that of separation of duties, which means basically if you have a role or a duty in your organization, you want to separate this among several individuals. This is a very powerful concept of internal controls, but it's also very costly to achieve. It's also referred to as SOD, or segregation of duties, or separation of powers. And this is really to prevent the abuse of power of one single individual being in charge, for example, of all of the security policy or of all of the access controls, or only one person having administrative control over a server system or a set of routers. No one person has authority over authorizing access to devices and authorizing access to objects. Only having more than one person in charge of documentation, having more than one person in charge of custody of assets. And this is very important with, let's say, certain mandates like Sarbanes-Oxley, which is in the financial industry, or SOX. You have multiple individuals that are responsible for identification, for authorization, for approval, for design, for development, for review. Okay? Separation of duties. Now, along with this goes the concept of job rotation, where somebody works in a particular job role. Let's say they might work as a comptroller of an organization for maybe 6 months to 18 months. Then you're going to rotate that person out of that particular job role into some other maybe parallel role or parallel title, maybe a vice president, something in finance. That way no one person becomes indispensable. By having more than one person trained at the same knowledge level and security level as another person and rotating them in and out, you aren't totally dependent upon one individual. It also gives us that prevention of abuse of power from a security standpoint. Okay, next I want to define 4 very important access control models: MAC, DAC, role-based access control, and rule-based access control. And I'm not going to write all this out, okay? So I'll need you to, if you can, try to take some good notes or outline this particular area I'm talking about, because you will be specifically tested on these access controls. Now, the first one is mandatory access control. This is referred to as a static model. In other words, you have a predefined set of access privileges to files on the systems, and the administrator or administrators manage the access controls. They establish the parameters. They associate these particular access privileges with accounts, with files, with resources. The MAC model is very restrictive. It's the administrators only who establish access. They're the only ones that can change access, and users can't share resources dynamically unless the administrators have statically created that relationship first. MAC will typically use labels to identify sensitivity levels. Labels like unclassified, secret, top secret, confidential. And depending upon where you are in the organization, you have access to this on a need-to-know basis, okay? So this really follows that principle of least privilege in a very strict way. Users can only access objects that they must be able to access to do their jobs, and that's it. And the administrators have complete control over this. The Mac model was developed for like the military and for the CIA, okay, for areas where confidentiality is the highest priority. And all the subjects get some type of clearance label, and then the objects receive a classification label, and those are mapped together, those security levels. So that's MAC, Mandatory Access Control. Discretionary access control, DAC, is actually one that we're more familiar with, okay? This is, for example, on this machine right here. Michael is the owner of the files on this machine. I own folders and I own documents. And as we saw earlier, at my discretion, as the owner of that particular folder, I was able to go in and grant security access to someone like James or someone like a guest. So even though DAC still uses that implicit deny aspect, it's at the discretion of the owner of the object to grant access. The problem with this is a pretty vulnerable scenario. Actually, it's quite vulnerable to Trojan horses because as a user, since I am the owner of a system, I can grant access to other applications, other users, which makes malicious users more able to take advantage of me because of my security level. So discretionary access controls allow the owners of resources to establish privileges on the data and the information that they own. Now, we can still use labels with DAC, but they're not mandatory like they are in MAC. Owners can grant or revoke access to individuals or groups of individuals on a situation-by-situation basis. So this is a dynamic model and one that produces productivity and collaboration and sharing of information easily between users, but it's also a lot less secure than mandatory access control. Let me go ahead and write out these acronyms before I go on to my next concept, role-based access control. Let me jot those down here for you real quick. Now, for a while, mandatory access controls and discretionary access controls are like the only game in town, but recently a more flexible and policy-neutral concept came about. And this is really a combination of MAC and DAC that really came about in the 80s and 90s, really came on strong, and that's role-based access control. So let's break down RBAC, or role-based access control. We're going to see later there's a rule-based access control, but that's not RBAC. When you hear RBAC, we're talking about this particular implementation, which has the ability to kind of give the impression or the results of both MAC and DAC, mandatory access control and discretionary access control. It's the best of both worlds. It's a dessert topping and a floor wax. Now, what we do here is we create roles for various job functions. Then we assign permissions to those roles, and those roles are things that we do in the organization. You'll see forms of role-based access control used in things like Microsoft's SQL. Well, they'll have different roles like the operator role. Microsoft's SharePoint MOS 2007 also has kind of a role-based mechanism where you have a bunch of permissions, and then permissions become permission levels, and then you assign those to different roles. But we're talking about hardcore various job functions in an organization here. Then the permissions are assigned to those roles. And one thing about RBAC is that users are never assigned access directly to an object. So this is a whole lot different than discretionary access controls, where a user can basically have read-write access or other types of other granular access to a folder or a file. RBAC is not an access control list method. It's a whole different application. In other words, with discretionary and access control list, we're saying basically what somebody can access and what kind of access. But this is different. This is saying what can people do. For example, we might say This person has the role of doing this particular action to a medical record. You can have several different people accessing that medical record, but they're in different roles. So they have different actions they can perform on those objects based on the role, okay? It's very granular. It introduces a role hierarchy in the organization and different types of constraints. And I didn't spell this properly. It's constraints. Sorry about that. A constraint places a restrictive role on the potential inheritance of permissions from opposing roles. So you can use this to achieve that segregation of duties concept that I had talked about earlier on. For instance, one woman shouldn't be able to create both a login account for an individual and also be able to authorize the procedure of creating that login account. Does that make sense? So she has different constraints on her. When you use an RBAC model, you use different conventions usually, and you'll create actual formulas that's kind of based on set theory. So what you'll have is you'll have subjects, and these are a person or a system or a service. You'll have roles, and that's the actual job function, or it could be a title, which is their authority level. Then you have permissions, and these are approvals of a certain type of access to an object or a resource. SC is a session, and a session is really a mapping of a subject, role, and or permission. You've also got the concept of subject assignment and permission assignment. So to break it down, what RBAC says is a subject can have more than one role. They can have several roles. A role can have multiple subjects. A role can have multiple permissions. And a permission can be assigned to many roles. Rule-based access controls are a little bit more esoteric, and this is not use the RBAC acronym. When we talk about RBAC, we're talking about role-based access controls that we just talked about there. A rule-based access control is kind of a combination form of MAC and DAC. So you've got access to resources based on administratively defined rules. And only the administrators, the designated admins, can define the rules. So users can't change any access controls. You do have access controls. You have access properties that are stored in access control lists. The access control entries in those ACLs are rules. Rules defined by admins. And like mandatory access control, users can't change the access controls. A little bit more esoteric, but in case they ask you on the exam, that's what a rule-based access control is. Now, we simply can't talk about all the different applications of these access control methods, and you really kind of want to start thinking about the environments that you've worked in, some of the scenarios you're in, financial organizations, medical organizations, and think about how these different models might be applied. What we're going to look at here is a very common discretionary access control mechanism that's used in the Microsoft world, and it's extremely popular, and it's a model that you need to know because it'll probably be tested on the exam, number one, and number two, it's often used. Now, what we do is this. We are going to have permissions, set permissions that are defined on a domain by domain basis. And a domain is simply an area of administrative and security control. Okay, it could be an organization. The domain could match up to, let's say, a DNS namespace like nuggetlab.com. Okay, or I could break this into subdomains and have east.nuggetlab.com and west.nuggetlab.com, and each one of these can be their own domains where we have our own security and administrative boundary. Okay, so I have a set of permissions that basically come with the network operating system that I'm dealing with. In this case, it'd be Microsoft Server 2003, Server 2008, for example. I'm going to assign these permissions to domain local accounts. Okay, local accounts in the domain. There's a bunch of built-in accounts that the operating system provides, but I may create my own domain local accounts based on my own structure. Then I'm going to nest groups together. So in other words, here's what's going to happen. I might have a user account, let's say it's J Conrad. Okay? I'm going to place J Conrad into a global group, let's say domain users. Then I'm going to nest this global group into another universal group that may be called something else. The reason I'm doing this universal group is because I may have multiple, let's say in a large multinational corporation, I may have huge forests of users. For example, let's say I'll just use Fujitsu for example. Maybe Fujitsu has a Asia unit, Asia.Fujitsu, and then maybe it has North America.Fujitsu. I'm just using this as an example. These could be two separate forests. I might want to have a user who travels from North America to Asia to be able to go within the Asia forest or Active Directory database and be able to log in there and get access to objects back in North America. So it's a trust relationship. So I place these domain user global groups into this universal global group, and then I'm going to place this universal group into the domain local groups, and those have permissions assigned to them. Now what does this do for me? Well, J Conrad, who let's say is in North America, is in a North America domain users group. He travels over to Asia. Because I've taken his account and I've placed it into domain users and then nested that into the universal group and then placed that inside of a domain local group and assigned permissions, this is a scalable solution. For example, if I hire some new individual in the organization that has similar types of access needs as J Conrad, let's say M Shannon, all I simply have to do is create this user account, put it in the domain users account, and automatically, since this domain users account is nested within a universal group and then placed into a built-in domain local group and assigned permissions, that particular user, M Shannon, automatically has all these same types of access rights and permissions that J Conrad does. And so all I have to really do is assign permissions to the domain local groups that apply to my organization, to the departments, to the way I handle resources, to the way we get access to objects, and then I just simply use this concept of nesting individual user accounts into global groups, and if necessary, nest those into universal groups. Remember, this is only going to apply if, let's say, in an Active Directory environment where I've got multiple forests in a large multinational organization. You could take this out of the equation and just say we place accounts into global groups and global groups into domain local groups, and we assign permissions to those domain local groups. There's a bunch of built-in domain local groups based on different types of roles. It's not role-based, but you've got backup operators and those kind of things. So based on different types of roles in the organization. So this is a common model for assigning permissions. And again, we can spend a whole nugget course on this concept, but you kind of want to understand that each one of these models has their own methods. For example, mandatory access controls will have their own kind of lattice of top secret, confidential, public, and then you'll have individuals who are at different security levels in the organization, and so things are applied that way. Now, I've used this concept of an access control list quite a bit, and really all that is just a list of permissions that's attached to an object. And then that list of permissions can also be associated with an individual user or a group of users or both based on their authentication and authorization as a particular user in a system. So what we simply really have is we have a user over here, and they'll have a set of credentials. I'm going to put creds. This can be usernames and passwords. It can be tokens. It can be smart cards. I'll put SC. It can be all different types of ways to authenticate the user for credentials. Then they are authorized to access different objects. Okay, files, for example, containers, data, services, okay, applications. And this information is stored typically as an access control list in some type of network operating system. The access control list is a list. It's a list of entries, or ACEs, ACE, access control entries. For example, an entry would give, Jane read and write and delete permissions on a particular file XYZ. Now, both discretionary access controls and mandatory access controls use ACL. Okay, these are all traditional ACL systems that assign permissions. But the ones we're most familiar with are the file system ACLs, where information is stored in a file system, let's say like Microsoft's Windows file system or OpenVMS or Mac OS X or Linux, and then each accessible object contains an identifier to its access control list, which stores all the access control entries. Now, we also use access control list in networking as well, and so we can have access control list used on routers and multi-layer switches and firewall devices to control access in and out of those particular devices, and they can be used, access controllers can be used to filter out particular IP addresses or entire networks. They can filter out TCP applications, UDP application, port numbers, all that type of stuff. So basically, access control lists are a key fundamental mechanism of discretionary access control in modern operating systems. Now, one of the best ways to manage this kind of access control in a large environment, because this isn't really a very scalable solution going user by user, object by object, is to use that nesting process that I showed you earlier, and then to implement this on different domain local accounts or organizational units, which are just logical containers, using what's called group policy. What group policy allows us to do is it allows a medium-sized to large enterprise organization the ability to define rules and policies and security structures that gives the systems the ability to enforce these automatically. We can use group policy to distribute software. We can use it to lock down systems. We can use it to enforce an existing security structure. A good design is going to group objects that are subject to the same policies in the same organizational units, for example, like sales and HR and IT. And of course, China and Japan each have their own organizational units, and as we see this is kind of a flow down from the top, and rights and permissions and policies are going to be inherited by these child objects as they're created down here. We basically create group policy objects, and we assign or attach those group policy objects, which have a wide variety of different attributes in them, to these different levels, to the organizational unit level, to the domain, to the forest. It's a hierarchical aspect. And we have lots of different GPOs or objects. We have local computer policy objects. We have domain policy objects. We have physical site objects. We can create OUs for domain controllers, which are the servers that hold the directory database, and logical organizational units. Now, the design of this is beyond the scope of this course, but to manage security policy and to enforce the delegation of authority for who has the administrative authority over rights and permissions in different organizational units and over different objects, group policy is a fantastic tool that can be used to do this. For example, I'm going to go to the local security policy on this Vista machine. And this is the type of thing that would be controlled with group policy based on my particular system's membership, let's say, in one of those organizational units. For example, Asia HR, for example. And I can push these policies out to a bunch of machines or to a bunch of users. Now you can see here I've got account policies and things like password policies. And these are the types of policy from a security standpoint that you're going to want to enforce in your organization. This is typically dictated from a written security policy standpoint, but I can enforce the password history. How many times do I have to use unique passwords before I can reuse a password? Okay, how many are remembered? The maximum password age, the minimum password length. password complexity requirements, 3 or 4 characters, for example, uppercase, lowercase, numbers, and symbols. I've also got account lockout policy. So, for example, if somebody attempts to log on with the wrong credentials, let's say 3, 4 times, that's the account lockout threshold, let's say 3, then the duration is how long are they going to be locked out? 5 minutes, 10 minutes, okay? Then I can reset the account lockout after, let's say, 24 hours or an hour. This prevents users from doing brute force attempts to log into a system. And so these are all the types of policies. Here's local policies that show user rights assignment. You can see all the types of things here that can be managed. This shows which security groups actually have these policies or rights. Okay, the right to debug programs. Only admins can do that. Log on locally. A guest, administrator, user, or backup operator can do this. So this looks like a role-based scenario here. The problem is it's discretionary. Now, I can change this right now. And these are user rights assignments, audit policy, things you're going to audit and generate logs for. Okay, for example, successful logon events, usage of admin privileges. Whenever I change account management, I want to create a log entry, and then security options. You can see a ton of different things here. So this is what we consider policy, security policy, and the best way to enforce this is with a group policy implementation, and Microsoft is famous for their group policy implementation. Next, I want to break down some authentication models, and there's really 3 main types of models, and then single sign-on is a way that we can leverage some of these models. Now, a single factor authentication is simply you have something you know or something you have. So a single factor could simply be you get a dialog box and you have to enter in a username and a password. And so a single factor, something you know, would be knowing that. When you go up to a website and you enter in a username and password or a PIN number, you have to know one thing, a single factor. Now, it could be an entry badge. If you've got a badge that you flash in front of a sensor to get into a door, that's single factor because it's only one thing. It's one thing you have. I can give that badge to some other person. They can run down to the restroom and come back in again. So that's still a single factor authentication model. Neither one of those are particularly strong, and one way to improve upon that is to go one extra factor. A two-factor authentication model is going to combine something you know with something you have, or something you have with something you are. Okay? It's 2 factors. It could be something you know and something you are. Let me show you what I mean. First of all, something you know might be, and this is very common if you use an ATM machine, something you know is a PIN number. Okay, a 4 to 6 numbered PIN. Something you have is your ATM card. Okay. Now this is also done with things like smart cards and one-time password tokens. For example, whenever I go onto PayPal, I use a little one-time password token, and whenever I go up to log on to PayPal, I have to first put in my single factor credentials, my username and password. Then I provide a 2-factor credential in the form of my RSA token. I will hit a button and it will generate 6 numbers, and I input those numbers and they're mathematically related or relevant, and I get authenticated. So I have the token, that's something I have, and something I know is the 6-digit number that is generated one time. So a 3-factor authentication can combine 3 things: something you know with something you have and something you are. Something you are could be some type of biometrics. Okay? And that could be in the form of fingerprint scanning, facial scanning, iris scanning, things like that. Let's take a little survey of different types of techniques that can be used. Now, before I do that, though, let me just tell you what single sign-on is. Enterprise single sign-on allows us to sign on one time, and then we get granted tickets. Well, I'll use Kerberos as an example. We sign on one time with our credentials, whatever they are, single factor, two factor, three factor, the stronger the better. And once we get signed on, we can get access to services and applications and data and files throughout the enterprise without having to authenticate over and over and over again, having to enter credentials over and over and over again, or use those smart cards over and over again, present biometric fingerprints over again. So we're granted tickets as we move through the system and access services and applications and resources. We're granted tickets by a ticket granting system, and that's what gives us that single sign-on capability. And that's a really great feature for large enterprise organizations to prevent users from having to sign on with IDs and passwords and other tokens in multiple applications in multiple locations. Here's a scanner. This can be used to scan like a smart card or a token. Here's an RSA smart card. You can see here's that 6-digit random number that's generated. So this is something you know and something you have. This smart card can be scanned. You'll see workstations, servers, routers, high-level switches that all have smart card ports on them. Here's some other smart card devices. Here's a fingerprint scanner. I have a fingerprint scanner on my Toshiba laptop, as a matter of fact. I've got software down here at the bottom. I don't know if I can show it to you, but here it is, Protector Suite QL. And if I'll just go ahead and say OK, this is the software that sets up my fingerprint scanner for me on this system. Iris scanning, this is obviously the iris of your eye, and it's totally unique. And you can see here's a new iris scanning machine that can be used in high security environments. And we're starting to see more and more airports use facial scanning. And so this is a new biometric technology. This is something you are. So something you know would be a password or a credentials or a passphrase. Something you have would be a smart card or a smart token. And then something you are is biometric, okay? Fingerprint, iris scanning, facial scanning. And so single, two-factor, three-factor are different combinations of those, and single sign-on can use single-factor, two-factor, or three-factor. It's just an enterprise system that allows you, usually with a ticket-granting system, to sign on one time to get full access to systems, services, data, and applications. Those are your authentication models. Okay, in part one of access controls, we covered 4 key areas, looked at some best practices, some access control models like MAC and DAC and RBAC, logical access controls, and then finally, authentication models. I hope this CPT Nugget's been informative for you. I want to thank you for viewing. We'll see you in Access Controls Part 2.